Linear functions. For each problem, you are given two collinear points. Find the slope of the line containing the points and indicate if the line is increasing or rising, decreasing or falling, horizontal or vertical. So first, recall that the slope formula, m for slope, is the ratio of the change in y, or delta y, divided by the change in x for any 2 points on the line. Delta y is y sub 2 minus y sub 1, and delta x is x sub 2 minus x sub 1. So if the first ordered pair is the x1, y1, followed by x2, y2, then the slope is 8 minus -2 divided by 2 minus -3, which is 10 divided by 5. So the slope is the ratio of 2 to 1, or simply 2. That's a positive slope, and therefore the line is increasing or rising. So as left to right, x increases, y values increase, and we also say the line is rising. Now in part B, notice that the x coordinates are the same. So when you graph those two, they'll fall on a vertical line, and the slope is undefined, which we can show by applying the slope formula. 5 minus 3 divided by -2 subtract -2 is 2 divided by 0. Division by 0 is undefined, so the slope is undefined, and the line graphed is vertical. Part C. The slope is y2 minus y1 is -1 subtract 4 divided by x2 -1 minus -5. So the slope is -5 divided by 4. A negative slope is a line that is falling. The linear function is decreasing, which means left to right as x is increasing, y is decreasing, and the line is falling. In part D, the y coordinates are the same. So when you graph these 2 points, they're going to be contained by a horizontal line. The slope is 0, which we can show by subtracting y2 minus y1 divided by x2 minus x1. So the slope is 0 divided by 2. The slope is 0. So the line is horizontal. The linear function that represents this situation is a constant function, meaning as x increases, the y value remains constant or the same. So we have a situation of a constant function. This graph is a horizontal line and the slope is 0. Number 2, graph the linear equation into variables by finding and locating its x-intercept and y-intercept. Should say its intercepts, x and y. So to find the x-intercept, a line will intersect the x-axis with the y coordinate of 0, so we plug in y is 0. So we have 2x plus 3 times 0 equals 6. So 2x equals 6 divided by 2, therefore x equals 3. And the ordered pair 3, 0 is the x-intercept. For the y-intercept, the graph of an equation will be a line that intersects the x-axis. Sorry, the y-axis will be the y-intercept, and the x-coordinate will be 0, so we let x equal 0. So substituting 0 for x, 2 times 0 plus 3 times y equals 6. So 3y equals 6. Therefore, y equals 2. And the ordered pair 0, 2 is the y-intercept. So let's graph 0, 2 and 3, 0 and draw the line containing these 2 points. And line is falling, therefore the slope is negative. And if we highlight these 2 intercepts with yellow highlighter, we can see the vertical rise is -2 because we're dropping down 2 units here. So the rise is -2 units, and the horizontal run is to the right. So the run is +3 units. So the slope, which is the ratio of rise divided by run, is going to be -2 divided by +3. Number 3, identify the slope and intercept of each line and write its equation in slope-intercept form, y equals mx plus b. So for line 1, the y-intercept is 0 at the origin, and the slope we can determine by using the graph and choosing 2 points on the line, like the origin. And let's highlight using yellow a second point. It's graphed a little darker. It's 3, 2. So we'll use rise and run from the origin to second highlighted point. The vertical rise is +2, and the horizontal run is +3. Therefore, the equation for line 1, y equals mx plus b, y equals slope rise over run is going to be 2/3 x, and b is the y-intercept, which is 0. So we can just write that as 2/3 x and leave out the +0. Now for line 2, 2 points on the line are 0, -2, the y-intercept, and 3, 0, the x-intercept. So let's highlight those in green here. So left to right, we have a vertical rise of 2 units. So +2, and a horizontal run of +3. So we can compute the slope. So for line 2, the equation is y equals mx plus b. It appears line 1 and line 2 are parallel, but we have to show that rather than just say they appear to be. So the slope is rise over run is positive 2 over positive 3 equals slope of line 1. So these are parallel lines, which we can express with this squiggles, or we can also use arrowheads to indicate parallel lines. And B, the y-intercept is -2, so we can write plus -2 or just -2. All right, let's talk about line 3. The y-intercept is 1. Let's highlight that in pink here. And a second point on the line is at 2, -2. So from left to right, we have a vertical rise. It's going down 3 units. So the rise is -3. And the horizontal run is to the right, so +2. So for line 3, the equation is y equals mx plus b. Y equals the slope, rise over run, is -3/2, which happens to be the negative reciprocal of the slope of line 1 and 2. And therefore, it's a line that's perpendicular. So -3/2 x plus b, the y-intercept is 1. Number 4, find the equation of the line that passes through the 2 given points. So let's label the first point 1, 4 as x1, y1, and the second point coordinates as x2, y2. So the slope of the line is y2 minus y1 is 2 minus 4 divided by x2 minus x1 is 4 minus 1, which is -2 divided by +3. So the slope is -2/3. So we can use point slope form. Y minus y1 equals the slope times x minus x1. And we can use either point. Let's use the first point, 1, 4. So y is 4. Slope is -2/3 times x minus 1. If we want slope-intercept form, we'll solve for y. So let's distribute the -2/3 and then add 4 to both sides. So y equals -2/3 x plus 2/3 plus 4 over 1. With the common denominator of 3, we can multiply by 3/3. So we have y equals -2/3 x, and then 2/3 plus 8/3 is 10. Correction, 2/3 plus 12 over 3 is going to be 14/3. Number 5, find the equation of the line parallel to the given equation passing through the given point. So lines that are parallel have equal slopes. So the first thing we have to do is solve for y to determine the slope of the given equation. So let's subtract 4x from both sides. So 3y equals -4x plus 3. And divide by 3 on both sides. Divide every term by 3. So y equals -4/3, which is the slope, plus 1. So a line that's parallel has an equal slope of -4/3. So this time, let's use y equals mx plus b, slope-intercept form, and substitute the given point y coordinate of 1 We now know the slope is negative 4/3 and substitute the x coordinate -2, and then we can solve for b, the y-intercept. So 1 equals 8/3 plus b. Therefore, b equals 1 subtract 8/3, which is 3/3 minus 8/3. So b is negative 5/3. So the equation of the line parallel passing through the given point is y equals m, the slope, negative 4/3 x, plus b, which is minus 5/3. Find the equation of the line perpendicular to the given line whose y-intercept is the same as the y-intercept of 2x plus 3y equals 6. So first part, let's determine the slope of the line perpendicular by solving the first given equation for y, so we can get it in slope-intercept form. So to solve for y, let's subtract 4x from both sides, and then divide every term by 3. So negative 4 divided by 3x plus 3 divided by 3. So the slope is the coefficient of the x term, negative 4/3. Any line that's perpendicular has a slope that's the negative reciprocal. So the slope of any line perpendicular is going to be positive 3/4. So now we know the slope of this line perpendicular. Now the y-intercept is b, is the same as the y-intercept of 2x plus 3y equals 6. So if we solve this equation for y, get it in y equals mx plus b form, then we can determine b, the y-intercept. So let's subtract 2x from both sides. So we have equals negative 2x plus 6, and then divide by negative 3 every term. So we have y equals positive 2/3 x plus negative 2, or simply minus 2. So b, the y-intercept, is negative 2, which is given as the same y-intercept of the line perpendicular. So for the line perpendicular, we know the slope is 3/4 and b, its y-intercept. So putting these together, the equation is y equals 3/4 x plus its y-intercept, which is negative 2. Same as y equals 3/4 x minus 2. So either are correct.